Hello, and thank you for coming to my quick talk. My name is Alexandra Howell. I'm a graduate researcher at the University of Wyoming. My advisor, Dr. Erica Belmont, and I would like to present our implementation and utilization of a hydrogen pyrolysis reactor, which we've used to isolate the pyrogenic carbon fraction, or the most recalcitrant fraction, of biochars. There are currently several methods for the characterization of biochars, specifically the physiochemical properties that dictate recalcitrance. These properties can help tailor the biochar manufacturing process to meet agricultural and environmental objectives for soil applications. Current characterization techniques are dominated by proximate, ultimate, O to C, and H to C analyses. For example, here you can see that as the thermal treatment temperature increases, the carbon content increases and the hydrogen and oxygen contents decrease. This is a good indicator that the biochars have been rendered recalcitrant to environmental degradation. But these metrics are difficult to utilize in monitoring a biochar after soil application. The pyrogenic carbon content, or PYC, which is the most recalcitrant fraction of the biochar, could indicate the durability of thermally produced biochars and could be used as a marker for monitoring of those biochars in soil over time. Pyrogenic carbon is a range of carbonaceous solid products remaining after incomplete combustion or thermal treatment, such as char and soot. It is present in a continuum ranging from lightly charred biomass to graphite. Most notably, PYC is highly resistant to environmental degradation and in this manner can act as a carbon sink. Knowledge about the quantities of PYC in carbon products can lead to information about the longevity of biochars. But to date, the quantification of PYC remains challenging and various techniques have been investigated with limited success. The difficulty in the quantification of PYC arises from the very nature of PYC itself, as it is present in a spectrum of carbonaceous products that each varies significantly in composition and environmental recalcitrance. Hydrogen pyrolysis, or HyPy, is a technique for isolating PYC that has been shown to capture the most recalcitrant portion of carbon products, such as biochars. HyPy uses high-pressure hydrogen and a catalyst to remove the labile species from organic samples without inducing the formation of additional aromatic compounds by the thermal treatment itself. Thus, HyPy isolates the most recalcitrant and aromatic compounds in the organic samples that were present before the thermal treatment. We have built and utilized a HyPy reactor for quantifying PYC in raw and charred pine samples. Samples loaded with a molybdenum precursor are placed in the reactor where the sample temperature can be monitored with a thermocouple. The reactor is pressurized with hydrogen to 15 megapascal and heated to 550 degrees Celsius, and the biomass sample is treated for 5 minutes. Once removed from the reactor, the sample has been reduced to its PYC fraction and ash only. We use this reactor to investigate the PYC contents of wildfire burned and unburned healthy and beetle-killed lodgepole pine, which I will refer to as HP and BK respectively. First, I want to demonstrate the validity of this HyPy technique. In this figure, I am showing thermogravimetric proximate analyses of 2 chars. Most notably, I am showing only the pyrolysis and oxidation steps so that we can observe the fixed carbon contents of the organic samples after their treatments. One sample is the post-HyPy treated sample, and the other is a thermally treated sample pyrolyzed in nitrogen. Both samples were unburned healthy pine prior to these thermal treatments. Since the sample was unburned prior to these treatments, we would expect the PYC fraction to be very small. However, the nitrogen pyrolyzed sample indicates significant charring. The hydrogen pyrolyzed char does not. It shows very little charring, indicating a lower and more accurate PYC content of this unburned sample. This nicely validates the HyPy technique, as this method did not artificially increase the aromatic fraction of the sample like the nitrogen pyrolyzed sample did. We then use this HyPy procedure to investigate the PYC contents of the other burned and unburned samples, which I'm showing here. You can observe that the 2 unburned samples and the sample that was very lightly charred are showing small quantities of fixed carbon, indicating small amounts of PYC, as they should. In contrast, the heavily charred sample is indicating significantly increased amounts of PYC. Thus, the HyPy technique is useful in quantifying the most recalcitrant fraction of biochars, which could provide data for the optimization of biochars for longevity in soils and monitoring of those biochars over time. Thank you for listening to our quick talk, and please feel free to reach out with any questions. You can find our contact information here.